Hello geometry students and welcome to another class. We are in section 10-4 today, and today we are talking about perimeters and areas of similar polygons. What I would like for you to be able to do by the end of this lesson is to be able to find the perimeter and areas of similar polygons by applying the property theorems or the properties and theorems of similar shapes. So let's jump right in with example 1. It says, describe how each change on the figure will affect the area. So right here we have this triangle, and let's just find the area of this triangle to kind of see what it is. So the area for a triangle is equal to 1/2 base times height. The base is 12 and the height is 5. So I can say area is equal to 1/2 12 times 5, which would get me 30. So right now, this triangle has an area of 30. But what happens when I double the height? So let's do it again and now make the height 10 just to see what happens. So I'm going to say area is equal to 1/2 base 12 times height 10. So now when I do that and I put all that into my calculator, 1/2 of 12 is 6, and 6 times 10 is 60. So notice the area is equal to 60 now. How does 30 and 60 compare to each other? So the area has doubled. So when the height doubled, the area doubled. What happens if we double the base? So this time, instead of a base of 12, the 12 is going to be 24. So we have area is equal to 1/2. The base is now going to be 24, and the height is going to remain 5. Well, in this situation, 1/2 of 24 is 12, and then 12 times 5 is 60 once again. So area is equal to 60. So notice when we doubled the base, the area doubled once again. Now, I'm just doing some of these examples so you can hopefully start catching on to a pattern. I'll show you that pattern after a couple more examples, but let's do some more and just compare what happens when we change properties in shapes. So in example 2, it says, describe the effect of each change on the perimeter or circumference and the area of the given figures. So it says the base and height of a rectangle with base 4 foot and height 5 foot are both doubled. So let's find the area and perimeter of the rectangle the way it is right now. So right now, the area is 4 by 5, the rectangle is 4 by 5. So the area is just base times height, which is going to be 20. And perimeter is going to be all these sides added up. So 10 plus 8 will be 18. This is what it is right now. But what happens if I double both of them at the same time? So let's find the new area and perimeter for a different rectangle. So area is going to equal base. So we're going to double the base. The base is 5, but now it's going to become 10. And the height is 4, but we're going to double it, and so it's going to become 8. Now our area is 80. And comparing the area of 80 with the area of 20, notice this time it increased by 4. So area is 4 times larger now. Let's try figuring out the perimeter. So if we have 10 and 10 and 8 and 8 for our new perimeter, so our new rectangle, I'll draw it over here just so you can see it. They wanted us to, with the base 4 and the height 5, I accidentally had those backwards, but that doesn't matter, are both doubled. So it would be 10 and 8 now. So we have 10 plus 8 plus 10 plus 8, or 20 and then 16. So area is going to equal 36. Well, this is interesting. Notice when we doubled the sides, the area got larger, but now when we doubled the size, perimeter right there. The perimeter is double. So the perimeter is doubled. Let's do that again. And all we're doing right now is just looking at the old shape, what's its area and perimeter, making some changes, what's its area and perimeter, and describe how those numbers are different from one another. So here it says the radius of circle J is multiplied by 1/5. So what's going to happen to the circumference and the area of this circle if now the radius is multiplied by 1/5? So first let's find the area and circumference. Area of a circle is equal to pi r squared. Well, if r is 10, then that's going to be pi times 10 squared, or 314 point, what is it going to be? I'm taking pi times 100, and that's getting me I'll just round it to 0.2. This is the area of this circle the way it is. Let's find the circumference. Circumference is equal to 2 pi r. All right, so that's going to be times pi times 10. So that's 20 times pi. And that is 62.8. Okay. So right now, the way this circle is, the way that we have it, the area is 314.2 and the circumference is 62.8. What happens if we take this radius and we multiply it by 1/5? How is everything going to relate then? So first of all, let's change our 10. The radius is going to become 2 because 1/5 of 10 is 2. So our new circle that we're going to find the area and circumference of would be quite smaller, and the radius will be 2, like that. Let's find the area and circumference of it. So area is equal to pi r squared, which is equal to pi times 4, which is about 12.6. So area is approximately 12.6. That's kind of interesting how that switched. And then we want to find the circumference real fast. So the circumference is going to equal 2 pi r, which is going to be 2 times pi times 2, which would be the same thing as this. So that would be 12.6 also. So what has happened in these two situations? How did I get from one to the other? How did I get from 314.2 to 12.6? And how did I get from 62.8 down to 12.6? How did those numbers relate to one another? Well, let's just divide real fast. Let's take 314.2 and divide it by 12. And I'm getting about 24.9. So 24.9 can round to 25. The area decreased 25 times. So in this situation, this area decreased 25 times. It decreased to 1/25 of the original. So notice that's very interesting that 1/25 is relating to this 1/5. You're actually going to see why on the next page. Now, how does this 62.8 relate to that 12.6? We'll divide them and let's see what we get. So 62.8 divided by 12.6, that's getting me approximately 5. So the area, or sorry, I keep writing area, I mean circumference. Sorry, the circumference is about 1/5. So circumference decreased to 1/5 of the original. So this is very interesting. Notice when we're talking about the circumference, it only decreased by 1/5, which relates to our scale factor. But then when we did our area, it reduced by 1/25, which is our scale factor squared. That's actually the pattern that we're going to be seeing. But all I wanted you to see here was how we were comparing the two values with before we had our proportions. So flip your page over, and this is actually a rule or a property of similar polygons. When we have two polygons that have a similarity ratio, we know that ratio is going to stay consistent for perimeters, and then you square it for areas. So let's just say that we have, I'll draw two shapes in here. I'll just draw two triangles. Let's say this is A, and then the bigger one has a side B. The similarity ratio between the two sides is A over B. For the perimeters, which is the distance all the way around, that ratio remains A over B. But for the area, it's quite interesting. It is going to square. So I'm going to have A squared over B squared. So the ratio that we get from the sides stays the same for perimeter, but it gets squared for areas. We're going to apply that down here in just a moment. So it says a circle has a circumference of 32 pi inches. If the area is multiplied by 4, what happens to the radius? Let's do this with numbers one more time so you can see this pattern up here at the top kind of take place. So a circle has a circumference of 32 pi. So we've got our circle, and the distance all the way around is equal to 32 pi. The area is multiplied by 4. So we can easily figure out our radius by just solving for the radius right here. So I can say 32 pi is equal to 2 pi r. The pi's cancel, and then divide by 2. I have 16 is equal to r. So in this situation, for the first one, for a circle to have a circumference of 32 pi, the radius would have to be 16. Now it says if the area is multiplied by 4, what happens to the radius? Okay. If our area is getting multiplied by 4, then it's becoming 4 times larger. How are we going to get this to get a 4 times larger area? Well, first we're going to find the area of this one, multiply it by 4, and then we'll get our new value. So I'm going to take this, find its area now, and then take that area and multiply it by 4. So area of this first circle is going to equal pi r squared. So then area is equal to pi times 16 squared. Well, that's going to get us, when we put all of that stuff into our calculator, pi times 16 squared gets us about 804. So the area right now is approximately 804. What's going to happen if we take that area and multiply it by 4? So now we're doing our big change. Our area, take it times 4. So area multiplied by 4. I'm going to take 804 times 4. And I'm getting about 3,216. So now I have a circle with area is equal to 3,216. What does the radius become? So what I'm going to do, I'm going to use my formula for the area. Area is equal to pi r squared. Set it equal to this number and see what happens to the radius. So I'm going to say 3,216 is equal to pi r squared. I'm going to divide both sides by pi, which that gets me about 1,024, approximately. Now we're going to square root both sides. And that's getting me 32. Notice what happens with this radius compared to this radius that we had over here. So we've got a radius right here for our first, and then we've got a radius right here for our second. So this is our first, this is our second, and notice what happened. 16 doubled is 32. So when the area is multiplied by 4, the radius is only doubled. That is because of this similarity ratio right here. If the area is increasing by 4, then that's the same thing as 2 squared. So that's how I'm getting the 2 here with the 2 lining up here if A has to be the same value. So I'm just going to say for our answer, radius is doubled. You're going to see how we can do or apply this property even more directly. Here, I just wanted you to show it in action and how that kind of pops up. Now we're just going to go straight into using it. So this says, given that triangle LMN is similar to triangle QRS, find the perimeter and area of triangle QRS. All right. We know that this triangle is similar to this triangle. So we need a similarity ratio. Our similarity ratio is going to be between 2 corresponding sides. So I can say, oh yeah, this side corresponds with that side. So let's set up our ratio. And I'm just going to go ahead and say that this one is A and this one is B, just so we can see it. So I'm going to have it 13 over 9.1. 13 over 9.1. And I'll go ahead and say A over B right here. So 13 over 9.1. And we want to set up a proportion. So when 13 over 9.1 is our similarity ratio, let's set that equal using our perimeter. So this one says the perimeter is 36. Well, our perimeter ratio says that A over B is going to equal A over B, essentially. So because the 13 corresponds with the big shape and the 36 for the perimeter also corresponds with the big shape, I'm going to put both of those on the top of my fraction. So I have 36 here. What I don't know is the perimeter of the small shape. So I'm just going to put a little p right here. Once you get this set up, you cross multiply and you're good to go. So I have 13p is equal to 36 times 9.1, which is 327.6. We divide by 13 on both sides, and the perimeter is going to equal 25.2. So what we said here one more time is, because of this similarity ratio, if I have a similarity ratio, then the perimeter is equal to that. So in other words, A over B is equal to A over B. While this one, for the area, that's going to be a little bit different, and we'll talk about that now. For the area, I still have AB for the areas, but for the sides, I'm going to square them. So for the area, I'm going to say A squared over B squared. So now, and I'm getting that from this up here. So now A is 13 squared. B is going to be 9.1 squared. And that's going to equal area over area, or 60 over, and I'll just put a capital A for area. So let's square both of those things and get those numbers. So I have 169 over 82.81, and that's going to equal 60 over A. Now we want to cross multiply. So that's getting us 169A is equal to 4,968.6. Sorry about that. For the last step, all we want to do is divide by 169 on either side, and I'm getting the area is equal to 29.4. So one more time, if it's perimeter, A over B is equal to A over B. For area, the ratio goes A squared over B squared equals A over B for that. All right, that's what we have for this lesson. I hope you have a great night, and I'll see you soon.